Good morning to all. Shrikant, can I start?
మేడం స్టార్ట్ చేద్దాం మేడం టైం పడుతుందేమో కదా
I think you are in temple, kada.
వెళ్తాం మేడం ఆన్ ద వే
Okay.
ఓకే మేడం థ్యాంక్ యూ
So good morning to all. Today Dr. Santosh is presenting vaporizers class. This topic is only basics only. It's not covering to all the A to Z. So in the basics, he'll start the vaporizers. Dr. Santosh, please start.
Thank you. Good morning, everyone. Today I'm going to present a little bit talk on vaporizers. And the scope of my presentation will be as follows.
జాయిన్ అవ్వలేదు అని చెప్పి ఇంతవరకు జాయిన్ అవ్వలేదు జనాలు.
గుడ్ మార్నింగ్ సార్ సంతోష్ గారు.
Sir. The scope will be as follows, sir. Introduction, definition of a little bit about vaporizers and the physics involved in it. Factors affecting vaporizer output concentration, classification, types of vaporizers, color codings, hazards, and I'm going to summarize the presentation. Coming to the introduction part, the first public demonstration of vaporization was demonstrated in the Massachusetts General Hospital in 1846 on October 16th. The
Santosh, voice బాలేదు.
Hello, ma'am, ఇప్పుడు ఓకేనా ma'am?
Santosh.
Hello.
Your voice is not. Okay.
ఇప్పుడు ఓకేనా?
Now okay.
The first public demonstration of vaporization is done in 1846 on October 16th, which is celebrated as an old anesthesia day. On that day, Dr. W.T.G. Morton demonstrated the utilization of ether as an anesthetic agent in Massachusetts General Hospital. With this procedure, the patient was administered ether and anesthetized, and the surgeon John conducted the surgery by excision of a swelling in the neck. And this is the ether inhalation that was used back in the day. It basically consists of a cotton dip in ether solution, and it is placed in a glass jar.
Santosh, your voice not audible.
Ma'am, if it is not.
Santosh, hello? Signals, please check your signals. Please check your signals.
Okay, ma'am.
Now
okay, ma'am. Okay. So this is the ether inhaler used back in the day. Basically, it consists of a jar which contains cotton balls dipped in ether solution, and the fumes will be coming out of this ether, and it will be the patient will be made to inhale those fumes through the mask which is provided in the basic vaporizer which was used in 1846. So what is a vaporizer? The definition is instrument that is the instrument designed to facilitate the change of a liquid anesthetic into its vapor and add a controlled amount of this vapor into a fresh gas flow or the breathing system. Whenever the fresh gas flows through the vaporizer, the main aim of the vaporizer is to provide some vapor of anesthetic liquid which is already stored in the vaporizer container, and that vaporizing agent, the anesthetic agent, will mix with the fresh gas, and it will be inhaled by the patient. It will be delivered to the patient through the tubes. And to understand this, we have to know a little bit basics about saturated vapor pressure, boiling point, heat of vaporization, specific heat, and thermal conductivity. I'm going to elaborate these things in detail. Saturated vapor pressure, the vapor pressure of a system at a given temperature for which the vapor of a substance is in equilibrium with the plane surface of the substance, pure liquid. All of the anesthetic agents are usually available in the liquid form. So the pressure exerted by the vapor of that liquid on the container, when it is in equilibrium with the liquid that is also present in the container, this is called as a saturated vapor pressure. And the boiling point is temperature at which the pressure exerted by the surroundings upon a liquid is equal by the pressure exerted by the vapor of the liquid. Under this condition, addition of any heat results in the transformation of liquid into its vapor without raising the temperature. That is called the boiling point. Basically, boiling point is a point above which if we give any temperature to the liquid, it will be converted into vapor. So these are the various saturated vapor pressure and boiling points of various anesthetic agents: halothane, inflorin, isoflorin, sevoflorin, desflorin, ether, and methoxyflorin. And out of which desflorin has the least boiling point, 22.8 degrees centigrade, and methoxyflorin has the highest.
Santosh, please
Ma'am.
check your signals and voice is not audible.
Signal is
Please check
okay.
your signals and voice.
Signals are
Disturbance
okay.
లేకుండా
Voice is to
చూసుకోవా?
be more. Signal is okay. Voice to be more.
Okay, sir. Okay, sir. I'll try to be loud, sir. So desflorin has the least boiling point of the anesthetic agents that we are using commonly, which is 22.8 degrees centigrade, and methoxyflorin has the highest boiling point, 104 degrees centigrade, in the available anesthetic agents that we are used commonly. Heat of vaporization, the number of calories required to convert 1 gram of liquid into vapor is called heat of vaporization. And specific heat, the quantity of heat required to raise the temperature of 1 gram of substance by 1 degree centigrade. If we are taking 1 gram of any substance, to raise the temperature of that substance to more than 1 degree centigrade is called the specific heat. It depends on two factors, considering the amount of heat that must be supplied to a liquid and stick to maintain a stable temperature when heat is lost during vaporization. And the second one is choosing the material to construct the vaporizer. This is basically very important to construct a vaporizer, because whenever the liquid converts into vapor, it loses some heat due to loss of energy, and the loss of temperature will reduce the vaporization capacity of that liquid. So the container that we the container which contains the liquid has to be suitably selected to maintain the balance between the temperature and the vaporization of the liquid agent that we are using while while administering anesthesia. And the most important part is the thermal conductivity. This is a measure of the speed with which heat flows through the substance. If you take any substance, the heat, usually the heat will be transmitted from the higher heat zone to the lower heat zone, that is hot zone to the cold zone. So the speed with which the heat flows is called measured as thermal conductivity. Vaporizers are made up of metals that have relatively higher thermal conductivity to minimize the temperature changes when vaporizer is in use. Thus, thermostabilization can be achieved while administering the anesthesia with these vaporizers. Splitting ratio, the ratio of bypass flow and the flow to vaporizing chamber is called splitting ratio. I'll be explaining about the bypass flow in later slides, but this is the basic definition of the splitting ratio, the ratio of bypass flow to the flow in the vaporizing chamber. It depends on the two factors: ratio of the resistance that is in the pathway. If the resistance is more, the flow in that pathway will be less, and if the resistance is less, the flow in the pathway will be more. And the second factor that influences the splitting ratio is total flow of the vaporizer. If you are giving if you are using higher flows of fresh gas, then the splitting ratio will vary according to the resistance and other factors. And factors affecting the vaporizer output concentration are fresh gas flow rate, temperature change, intermittent back pressure, carrier gas composition, and barometric pressure. When we come to the fresh gas flow rate, if the flow rate is high, then the output will also be high, and the flow of fresh gas that is entering into the vaporizing chamber will be more. So the vapor that mixes to the fresh gas will be more. So the output will be more. The vaporizer output concentration will be more if the fresh gas flow rate is less. And vice versa, if the flow rate is low, then the vaporizer concentration will also be low. The second thing is temperature change. When the chamber is heated or the temperature is high, then the reactivity of the liquid that is present in the vaporizing chamber will be high. So the amount of vapor production will be high, and the concentration of the vapor that is coming out of the vaporizer will be more. So the temperature is directly proportional to the vaporizer output concentration. If the temperature is high, the output will be high, and if the temperature will be low, then the output will be also low. Intermittent back pressure, I'll be explaining in detail about the intermittent back pressure in the later slides. Then next, coming to the carrier gas composition, the few gases are more dissolvable in liquids when compared to other gases. Like nitrous oxide is more dissolvable in body fluids and other liquids, whereas the normal air or a medical air that we're using will be comparatively less dissolvable in the liquids that are using that will be used in our anesthesia machines. And barometric pressure, it is basically the altitude at which we are providing the anesthesia. If we are providing in higher altitudes, the pressures of the gases will be very less. So the flow rate has to be increased to increase the output, vaporizer concentration output. And if we are providing anesthesia at sea level or below the sea level, the barometric pressure, the atmospheric pressure will be little bit high. So the speed and the speed of the fresh gas that has to be administered, the flow of the fresh gas that has to be administered will be variable according to the atmospheric pressure at which we are providing the anesthesia. And back pressure effect, this is basically, it can be seen in the picture. Usually what happens is, whenever the fresh gas is administered, it is divided into two chambers, that is bypass pathway and the vaporizer chamber. In the vaporizer chamber, it mixes with the vapors that are present in the chamber, and it will come out of this outlet, and it mixes with the bypassed fresh gas, and it will be delivered to the bellows or bag that we use to ventilate the patient. Whenever we are compressing the bag, some amount of the air will be back pressure. Some amount of air will be and re-entering into the system, and it causes a little bit of pressure, little bit of pumping effect in the vaporizing chamber. Because of this pump, the vapors that are present in the vaporizing chamber will be accumulated, and it might mix with the fresh gas at the inlet end. So this is called pumping effect. Whenever the bag is relaxed, the entire amount of the flow which is already present in the vaporizing chamber and the bypass chamber comes out of the outlet valve, and it will be administered to the patient. So because of this pumping effect, the air present in the bag will re-enter into the circuit, and the concentration of vapor that is present in the circuit will be more when we give the breath to the patient next time. So this is the pictorial depiction of the same. When the bag is inflated, the amount of fresh gas from the bypass channel and the vapor channel will come and enter into the bag, and the re-entry of vapor can be seen in this place at the inlet valve. And the second effect is pressurizing effect. Because of the backflow of air, it will cause some pressure, but the volume of the vaporizer container will be same. So according to the various gas laws that we studied in our college time, if the pressure is more, the volume will be less, and the volume is more, and vice versa, the pressure will be high at a particular temperature. So with the increased backflow, the pressure in this container will be raised. So the amount of vapor that mixes with the fresh gas will be increased, and finally the outcome at the outlet, the vapor concentration will be high. So coming to the classification, this is the older classification. It is basically divided into 6 types. Method of regulating output concentration calibrated variable bypass and measured flow. It can be divided by the resistance that is applied to the vaporizer. One is clean type, and the second one is the draw over type. The third one is method of vaporization. Vaporization can be through 3 methods: flow over, bubble through, and injection. And the fourth concentration is the temperature compensation. The temperature can be compensated, or the supply of heat to maintain the equilibrium can be done. Fifth one is the agent specificity, and sixth one is vaporizer in circle or outside the circle of the bearing system. Well, coming to the newer classification, few classes from the previous classification have been omitted, and this is for our convenience. The method of regulating output concentration: number 1, concentration calibrated, and the second one is measured flow. Other type of classification is method of vaporization. This is already we've been discussed in the previous slide. Flow over, bubble through, and injection. Temperature compensation. When coming to the temperature compensation, thermo compensation, and supplied heat. These three are the major classification that we are following as of now. I'm going to discuss a few of them in detail. The concentration calibrated vaporizer. In this, basically, there will be two dials. The first one is to adjust the flow of fresh gas, and the second one is on the right side. It is to control the flow of the anesthetic agent. So whenever we are giving the fresh gas into the vaporizer, some amount of the fresh gas will be bypassed and it will go in a straight pathway, and some amount of the fresh gas will enter into the vaporizing chamber, and it gets mixed with the vapors that are present in the vaporizing chamber with the liquid anesthetic agent, and it will come out of this. And when we rotate this dial, the concentration of the vapor that mixes with the fresh gas at the outlet can be controlled and precisely controlled. These vaporizers also have some filling port on at the right, so that whenever the liquid gets exhausted, we can fill the agent again. This is the concentration calibrated, basically variable bypass vaporizer. And the second one is measured flow vaporizer. It contains basically a vaporizer is present with a two set of tubing. One is with a fresh gas, and second one is for the outlet. It has a regulator at the machine end, so that we can measure and regulate the flow of fresh gas which can be entered into the system. So when we open this green knob, as you can see in the picture, the green knob, the fresh gas enters into this pipeline and it will directly go to the patient. So we are bypassing the vaporizer and we are only giving the fresh gas to the patient. If we open this white knob that is present in the second line, then some amount of the gas enters into the vaporizer, and it will bubble through the liquid that is present in the vaporizer, and it mixes with the vaporizer, it mixes with the anesthetic agent and enters into the system. And at the outlet, both of these gases will mix with each other and it will be delivered to the patient. And we have a regulator to monitor and regulate the amount of concentration that can be flowed through the system. Depending on the type of vaporization, there are three types: flow over, bubble through, and injection. Flow over it is basically a stream of carrier gas passes over the surface of the liquid. It is most commonly used. Efficiency of evaporation has been increasing the surface area of the carrier gas, gas and liquid interface. To increase the surface area, we have several tricks under our sleeves. Basically, we incorporated wicks and baffles in the vaporizer system. It is basically the same principle as we light diya while our lamp lighting ceremonies. Basically, the tip of the wick is in the air and the bottom of the wick is dipped in the solution. So the liquid agent that we are using, the liquid anesthetic agent that we are using to anesthetize the patient, so that the anesthesia liquid that is present in the reservoir comes to the tip of the wick through conduction. So whenever the gas flows through the wicks with an increased surface area, the more amount of vapor will be mixed with fresh gas and more amount of concentration will be delivered to the patient. Bubble through, in this, the fresh gas will be passed through the liquid agent, and as it is an air in a liquid, so it causes bubble formation. So these bubbles will be coming out of the liquid and it will enter into the vaporizing chamber. When it comes to the vaporizing chamber, it is already coated with the anesthetic agent. So these bubbles will burst out and form a anesthetized and fresh gas mixture. This mixture will pass through the outlet and it will be delivered to the patient. And the third type of vaporization is injection. Vapor concentration controlled by injecting a known amount of liquid anesthetic agent from a reservoir in the vaporizer from the bottle into a known volume of gas. So if we are giving 5 liters of fresh gas, and just imagine if we are giving 1 liter of fresh gas to the patient, and the amount will be calculated, and the calculated amount of anesthetic liquid agent will be inserted into the fresh gas. So, for example, for 1 liter, if we say 1 liter of fresh gas is replaced, and we will be giving 100 ml of anesthetic agent. So, the total will be 1.1 liters of fresh gas mixture will be delivered to the patient. If we are multiplying the fresh gas flow, if we take 5 liters of fresh gas and 500 ml of 500 ml of anesthetic liquid will be injected into the fresh gas, and the mixture will be delivered to the patient. This is the injection system. And coming to the thermal compensation, as I've already discussed, when the liquid converts into vapor, it loses heat. So when the liquid loses its heat, the next set of vaporization will be reduced. To avoid this temperature regulation on the liquid vaporization, we have incorporated some system, as you can see in the bottom picture. It has a temperature control rod which is equipped with a block kind of thing to minimize or maximize the flow of fresh gas into the vaporizing chamber. As you can see, when the temperature is high, the bottom left one, when the temperature is high, the control rod will be straight, blocking the amount of fresh gas that enters into the vaporizer. So it limits the fresh gas flow through the vaporizer. So limited amount of fresh gas will enter into the vaporizer, and limited amount of vapor will mix with the fresh gas, and it will be sent out through the outlet to the patient. When the temperature is low, when the vaporizer temperature gets cooled, the green side of the temperature control rod will contract, so, and which exposes the blockage between the vaporizing chamber and the flash flow chamber. So the fresh gas which is entering into the vaporizing chamber will be more. So the volume of the fresh gas that enters into the vaporizing chamber will be more. So the more volume of air enters into the chamber, more vapor will be mixed with the air, and more concentration will be delivered at the patient end. So this is how the thermocompensation works. Basically, when the temperature is high, the flow will be limited. When the temperature is low, the flow will be more. So the vapor conversion will be more, and ultimately the amount of anesthesia delivered to the patient will remain the same. Come to the supplied heat. An electric heater is used to supply heat to the vaporizer and maintain a constant temperature. This is the second type of thermostabilization, in which we'll be providing an electric coil heater so that the temperature of the vaporizing chamber will remain same. Coming to various types of vaporizers, the first one is Boyle's bottle. It is a multiple agent type, and which means we can use several agents like ether, trichloroethylene. So these liquids will be poured into the bottom jar. Flow over or bubble through type of this is a flow over or bubble through type of you can see the various parts of Boyle's vaporizer in this. It basically has a container or a jar which contains the anesthetic agent in liquid form, and it has a U-shaped tube through which the fresh gas will enter into the chamber. So the next image I can show you. Yes. So this is the normal Boyle chamber in off position. This is the lever this is basically a mechanical lever, whether to make it on or off. Now when it is in off position, the fresh gas from the left side will enter into the chamber, and it will pass through, and it will go in this direction, and it will directly go to the patient end without mixing with the vaporizer or without mixing into the anesthetic liquid. When we keep it in the open position, the mechanical lever will be reversed. So the fresh gas which enters into the vaporizer will be passing through the U tube that is present in the Boyle's vaporizer. And whenever it comes in contact with fluid, liquid anesthetic, it gets vaporized, and, and this flow of fresh gas on the liquid of anesthetic will mix with the vapor, and it will be delivered into the patient and through this. So this is the basic principle of Boyle's bottle vaporizer. The next kind of vaporizer is Goldman vaporizer. It is A single vaporizer for use as drawer within closed circuit system was designed by Goldman. It has no temperature compensation. Maximum concentration never exceeds 2% irrespective of total gas flow. It is a low efficiency vaporizer except during splashing when we splash the liquid which is present in the bottle, the amount of vaporization will be more, so it will reach up to 5% of the concentration. And the next one is raw bottom vaporizer. It is basically the same as Goldman's vaporizer with a wick in the center. So basically this wick will increase the surface area of the vaporizing chamber. So whenever the fresh gas enters into the chamber, it has more contact area and more vapor will be incorporated into the fresh gas and it will be delivered to the patient. And the next one is EMO vaporizer. It is basically Epstein, McIntosh, and Oxford inhaler. It is also a variable bypass, concentration calibrated, draw over or flow over type of vaporizing technique is used. It is agent specific and it is labeled over here. Ether is the major agent which is used in this. The temperature will be compensated and the vaporizer, this vaporizer is incorporated within the circuit, so the flow will not be disturbed. Used as control and spontaneous ventilation. As you can see, this is coupled with the Oxford bellows mask. Basically, the temperature compensation happens in this place, and this is the bellows which is same as we use in our modern machines. Whenever the gas flows into this, it will be inflated, and whenever gas flows to the patient, it will be collapsed. And this is the mask through which the patient inhales the anesthetic agent along with fresh gas. So fresh gas enters into this place and it mixes with the ether or whatever anesthetic agent that is present in the vaporizer, and it will come out of this and it will be inhaled by the patient. Next one is copper kettle. It is described in 1952. It is measured. It is in this a measured flow of oxygen is allowed to bubble through the anesthetic liquid. As you can see in this pictorial diagram, the inlet is at the bottom. So whenever we pass oxygen or any air into this copper kettle vaporizing chamber, it gets passed through this series of tubings, and from here it forms bubbles in the liquid, and these bubbles will come out of the surface and they burst out and they release oxygen mixed with the anesthetic agent, and this mixture will be passing through this pipeline and it will come out of the circuit to the patient then through this outflow valve. And if the fresh gas flow is reduced, the sudden anesthetic concentration may be dangerously delivered to the patient in this kind of vaporizer. So later on, this was omitted. From then, with advancing time, they have incorporated various safety measures to develop the vaporizer so that the vapor concentration that is delivered to the patient will remain same. Modern day vaporizers, these are like specific vaporizers, Tech 2, 3, 4, 5, 6, and 7, which are developed by GE company. And this is Tech 2 vaporizer. This is the pictorial diagram of Tech 2 vaporizer. It basically has the same thermocompensation mechanism at the center. It has a metal rod at the center, as you can see. This compensates the temperature, and it has a inlet valve where we can fill the liquid anesthetic agent, and it is the controller. So when we rotate the knob, the amount of concentration that has to be delivered to the patient will be adjusted with with using this. And A is the inlet valve, interway admits to the fresh gas. When the piston is closed and in off position, the only fresh air will be fresh gas will flow through the channel and it will be delivered to the patient. When we open this knob, then some amount of air, some amount of fresh gas will be entered into the vaporizing chamber. It goes through all the wicks that are present in this and it mixes with the vapor, and this vapor will be transmitted to the main pipeline through this channel. and it mixes with the fresh gas and forms a mixture of anesthetic and pressure and will be delivered. To minimize the pressure effect and pumping effect, there will be pressure control valve located in this place. It is an unidirectional valve, so it allows air only in this direction. It prevents the reverse flow of any gas that is present in the pipeline. So whenever we bag the patient, the excess amount of air, fresh gas or mixture will not come back to the vaporizing chamber because of this pressure valve. So this is the safety mechanism that is incorporated in Tech 2 system uh, to prevent the pumping and pressurizing effect. The next one is Tech 3 vaporizer. It's of variable bypass and flow over type. It's both temperature and flow compensated. It used for halogen, isoflurane, enflurane, and fluoroflurane. It has a bimetallic strip in the as you can see, it has a bimetallic strip to compensate the temperature, and it has larger bypass compared to the Tech 2 vaporizer, and the dial base can be 0.5 to 5% of vapor that can be mixed with the fresh gas. These are the major differences between Tech 2 and Tech 3 vaporizers. The vaporizing chamber is rounding shape, which has a capacity of 150 milliliters. In Tech 3, the capacity will be around 70. Bypass, only one bypass is available in Tech 2 vaporizer. In Tech 3, two bypass chambers are available. And effect of back pressure, that is basically pumping effect and pressurizing effect, will be increased in Tech 2 vaporizer, very negligible in Tech 3 vaporizer. The accuracy in Tech 2 is a little bit low when compared to the accuracy of Tech 3 vaporizers. The calibration is up to 4% of MAC, and in Tech 3, the calibration is up to 5% of MAC. The metallic strip, which is present in the chamber in Tech 2 vaporizers, whereas in Tech 3 vaporizer, it is present in the bypass. So this is the metallic strip, as you can see here. This is the metallic strip which is present in the bypass channel, whereas this is the vaporizing chamber. So some amount of gas will enter into the vaporizing chamber here, and it mixes with the vapor inside in the vaporizing chamber, whereas the metal strip present in the bypass pathway. So the amount of fresh gas that enters into the system will be regulated by the temperature and volume, depending on the vaporizing capacity and other factors which are involved with it. Next, coming to the Tech 4 vaporizers, it is the first vaporizer to incorporate interlock system. In this, there is an interlock. Excuse me. So that it has an interlock basically to avoid simultaneous uses of two vaporizers at the same time. I mean, it is basically has an interlock where one vaporizer will be available at a time. So only we can use either isoflurane or sevoflurane. Any one of the vaporizer, the second will be automatically shut down, so that two agents will not be mixed together to deliver the patient in the fresh gas. And the major principle remains the same. He has an inlet. The air will be bypassed. One half of some percentage of fresh flow will enter into the vaporizing chamber, and some amount of fresh flow will enter into the vaporizing chamber. So bypass will come out of this pathway, and the vaporizer will come out of this pathway. Both of them will mix in the common outlet, and it will be delivered to the patient. It has a series of wicks to increase the surface area inside the vaporizing chamber. So the more amount of vapor is available for the fresh gas to be mixed with, and it has a filler at the right bottom. Whenever the anesthetic agent is utilized or exhausted, we can refill it with fillers. Coming to the Tech 5 vaporizer, it is also made by GE. This is the first system to incorporate IPPV assembly inside a vaporizer. What is an IPPV assembly? This is a positive pressure ventilation. It creates a positive pressure so that the temperature as well as the pressure will be maintained within the within the vaporizing chamber. Uh, so for the last four previous generations, we have only control on the temperature of the vaporizer. But in fifth Tech 5 vaporizers, they have incorporated positive pressure assembly. So the pressure as well as the temperature can be kept constant so that the volume of the fluid, fresh gas that enters and leaves the vaporizer can be maintained, adjusted, and precisely controlled so that the safety to the patient will be more. Remaining working principle will be the same. The bimetallic thermostat to control the temperature will be at the bottom, and it has a series of wicks to increase the surface area of absorption. So the inlet will be divided into a bypass and one to the bypass channel, and the second one is to the vaporizing channel. So the bypass will be going in this pathway. It will go to the thermostat valve. So the temperature regulates the flow, and temperature will remain constant. Whereas the gas that enters into the vaporizing chamber, will pass through this IPPV assembly. So the pressure will remain same, and the vapor that is present inside the liquid agent will come out and mixes with the part 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 of fresh gas that enters into the vapor, and both of them will mix here in the outlet, and the amount will be delivered to the patient. It has a rotatory valve concentration dial, so we can adjust the concentration how much we want to deliver to the patient. And this is the wick stick which is within the liquid, and this is the filler where we can fill the liquid agent whenever needed. So these are the major differences between Tech 4 and Tech 5 vaporizers. Vaporizing chamber is smaller in capacity, whereas in Tech 5 it is large in capacity, almost double to triple. The quantity of liquid that can be placed inside the chamber will be 135 ml when it is dry, and 100 ml when the wicks are wet, because the wicks will absorb the liquid agent, and the amount of liquid agent will be less when the wicks are wet. In Tech 5 vaporizer, the 3 ml is the quantity that can be put into the chamber, and 225 when the wicks are wet. Thermostat present in the center of the vaporizer, whereas the thermostat is present in the base of the vaporizer in Tech 5 that we already seen in the previous slides. Concentration control dial. It is little bit complicated, whereas very simple and easy rotatable knobs in Tech 5 Tech 5 vaporizers. The accuracy will be little less when compared to 5, and little more when compared to third generation Tech vaporizers. Whereas Tech 5 has more accurate delivery, and Tech 4 requires an annual service, whereas the Tech 5 requires once in 3 years. While coming to the next generation of vaporizers developed by GE, it is Tech 6 vaporizer. It is basically agent specific only for desflurane, because the desflurane has the least boiling point out of the lot. The boiling point is 22 degrees centigrade, which is way less than our room temperature. So if we keep the desflurane even at room temperature, the evaporation rate will be very high, and the amount of gas that is produced, the amount of vapor that is produced will be very high. The amount that mixes with the fresh gas will be very high, and the amount that delivers to the patient is also very high. To avoid this high flow, high delivery system, they have developed this special vaporizer exclusively for desflurane. It basically has a heater, coil heater, and it also requires a power supply. So whenever we are using desflurane vaporizer, we have to connect it to the power supply, and the power supply will be basically to generate a heat inside the chamber. So whenever the liquid gets heated, the amount of vapor will be more, and it has series of valves to control the amount of flow. So the desflurane will enter into, this is the liquid chamber. Whenever the heater is heated, it converts the desflurane liquid into vapor, and this vapor will pass through this channel, and this is the dial of concentration. We can reduce or increase the desflurane. It basically has 100% desflurane which is coming out of this, and it mixes with the fresh gas, and it will go up. If the pressure of fresh gas is more, it gives a signal to the CPU that is present inside the desflurane vaporizer. So differential pressure transducer will be there inside the circuit. It automatically reduces the amount of desflurane that passes through the jam. So it is a safety mechanism. It is again a safety mechanism in which if the gas flow is high, it limits the desflurane through internal transducer system. So the amount of desflurane that is coming out of the system will remain same. Tech 7. These are the modern day vaporizers most of us have seen and regularly using in our system. In our institute, we have this vaporizers assembled to our workstation. It is also a temperature compensated plenum vaporizer. Basically, it has different vaporizers for halothane, enfluorine, sevoflurane, isoflurane. There is a release button that must be the extra safety measure that has incorporated in this vaporizer is there will be a release button on the back side of the wheel. This is the zero indicator. Exactly opposite to this place, there will be a knob. When we push that knob, then only the vaporizer ball will be rotated here and there. So the concentration which comes out of the vaporizer will be regulated. So it is an extra safety measure that is incorporated in this X7 vaporizer. Without locking, without pressing that lock, we cannot rotate the ball. So the wheel that is present on the vaporizer will not be turned left or right. So the leakage of anesthetic agent, liquid agent will be less. It has a greater accuracy from 0.0 to 5, and even in some times of vaporizers, it will be up to 8 or 10 Mach. Greater accuracy of fresh flow gas 5 liters per minute. At higher flow rates and higher dual settings, there is a decrease in output. The innovative non-spin system in Texan vaporizer limits the movement of liquid agent if the vaporizer is tilted or inverted. Even if you invert the vaporizer, the liquid will not come out of the reservoir. That is a safety mechanism incorporated so that the movement of transport of the vaporizer can be safer. Otherwise, when we tilt or when we rotate, invert the vaporizer, the liquid that is present in the reservoir will come out of the system, and it will be it will cause an accidental inhalation by the providers. So to avoid this hazard, we have incorporated another safety mechanism to maintain the liquid level even if we invert or tilt the vaporizer. And this is the vaporizer mounting unit. It has 2 pins and a locking system at the center. So whenever we use these kinds of vaporizers, they will be mounted on this. Most of our systems have 2 mounting units, so we can use 2 vaporizers at a time. I mean, we can mount 2 vaporizers, but we can use only one vaporizer at a time. And the back part, as you can see, this is the lock. Whenever we place the vaporizer on the mount, it will be sitting in the it will be sitting on the pins that are available, and we have to lock the vaporizer so that the accident fall or slip and other physical damage can be avoided. Next company is Dagger Vaporizer. It works on the same principle where the temperature will be maintained and the pressure will be maintained. But usage of a single vaporizer at a time is incorporated through this lever system. In this, if we turn one vaporizer on, the rest of the vaporizers will be in off position. So these pins that are present above the rotator dial will be aligned like a key system. So when we turn one key, the rest of the 2 keys will be blocked. So the rest of the 2 cannot be opened. It is basically an extra safety feature that is incorporated to avoid multiple agent induction at the same time. And latest generation vaporizers, the latest GE machines are equipped with Aladdin vaporizing system. It is basically, the principle will be the same, but more and more safety precautions have been incorporated. It is basically an automated system in which there will be one CPU which controls the basically a computer which controls the flow rate. So when we want to deliver some amount of vaporizer, some amount of anesthetic agent to the patient, we will set that in the computer, and the computer will automatically maintain the temperature, will automatically maintain the flow of the system, will automatically maintain the volume that flows, and it automatically adjusts every setting and delivers the required amount of anesthetic agent to the patient. So this is the CPU that controls the flow control valve. And when we rotate the dial and when we want to adjust the flow, we will adjust with the rotator knob. So the system will receive an input from the rotator dial, and the CPU get activated. It will control it will act on the flow control valve, and it will regulate the flow that goes into the vaporizing chamber. And it is also a bypass type of vaporizer. The fresh gas comes from the inlet. It will be divided into two pathways. One is for the vaporizing chamber, and the second one is direct pathway. And the direct pathway will go in this way, and the vaporizing pathway will go into the vaporizing chamber, where it mixes with the liquid agent that is present in the reservoir, and the liquid vapor that comes out of the vaporizing chamber will be controlled by the CPU that with the input of our system. And this is the schematic diagram where there are multiple wicks to increase the surface area of metal wicking material to increase the surface area of the contact. And it has a rotator knob and a liquid level indicator filling system, and it has a handle and a locking system. And it also has one identification magnet positions. This is basically different for each and every vaporizer that is available. Basically, isoflurane has a separate pin system, sevoflurane has separate pin system, desflurane has our own pin system, and halogen. Likewise, every anesthetic agent has separate pin system to prepare extra and to have an extra safety. Why is this important? Is basically the boiling points of each and every anesthetic agent is different. If we use the same amount of temperature, same amount of pressure with desflurane, the amount of desflurane that comes out of system will be very high. It will be dangerous for the patient. If we use the methoxyflurane as an induction agent, as the inhalational agent, then no amount of vapor will come out of the system. So to adjust accordingly, the CPU is calibrated, the system is automated and calibrated so that it recognizes the it recognizes the vaporizer that we are placing in the system, and accordingly it changes all the settings, the temperature settings, volume settings, pressure settings inside the computer, and will automatically release amount of gas that is required and necessary to the patient, so that the surgery will be very safe. And this is the isoflurane Aladdin vaporizer and a handle. And this rotator knob is like a genie. That is, forgive me if I am wrong. I felt like this is Aladdin lamp. Whenever we rotate or rub the lamp on the side, it will give the genie, and it will automatically does everything what we need to do. So in the same way, I feel like I felt like that. When we rotate the knob, the system will automatically do everything that is required to maintain the fixed amount of gas flow to the patient. Other companies have already developed other type of vaporizer. The major principle will be the same. This is the flow diagram of Penlon vaporizer. Penlon Sigma vaporizer, and it has a vaporizing chamber with and zero lock port bypass. And it is also a bypass system. So this is the fresh gas direct flow, and this is a bypass system. So the fresh gas, this is the rotator knob. So whenever we want to increase the flow, we will rotate this dial. So the vaporizing, the anesthetic agent that mixes with the air will be more in this kind. The next one is Diva. This is another type of system, basically direct injection anesthetic vapor. Basically, reservoir has some volatile agent. It will be drawn into another smaller compartment. From here, the amount, whenever we give an input to the system, the CPU will automatically inject some amount of liquid that is necessary to vaporize the patient, and it will be vaporized in this chamber. It will go to the flow sensor. The fresh flow will enter into the system, and it will be sent to the patient. This is the latest, recent Anaconda vaporizer. This is basically present at the patient end, not at the machine end. So in this is incorporated when it is incorporated circuit. It comes the fresh gas comes to this place, and this is another line for volatile infusion line. This is basically anesthesia agent line. So the anesthetic liquid anesthetic comes into this chamber. There will be an evaporator inside the anaconda vaporizer. So it gets vaporized here, and it will be incorporated into the fresh gas that is flowing in upper circuit. So both of them will be mixed inside this chamber, and this mixture will come out of this, and there will be a gas sample, and so that we can always monitor whether the mixture is mixed with agent or not, and whether the fresh gas is flowing or whether the only vaporizer is going, only vapor is going. So we can monitor that the outflow through with this gas sample line, and this is attached to the ETP of the patient. And color coding system, to avoid confusion, they have color coded the vapors: red for halogen, yellow for sevoflurane, purple for isoflurane, and orange for enflurane. Bottles, adapters, assemblies, tubes, everything will be in this same color. It also some of them have already incorporated a keyed system, just like our keys, so that the cross connection can be avoided. These are the different vaporizers, and these are the fillers that can be seen in the right upper bottom corner. And lastly, coming to the hazards: incorrect agent. When we, if an agent is high potency or volatility, it is also vaporizer. For agent to low potency or volatility, a dangerously high concentration may be delivered. The vaporizer must be completely drained and all liquid discarded. Gas should be allowed to flow through it until no agent can be detected in the system. Tripping: when the when whenever when we fill the vaporizer chamber, some amount of liquid might enter into the bypass chamber where the fresh gas flows. So the first breath that patient takes will be very high flow, very high concentrated. The next will be normal. Overfilling might cause leak of the system, and the other hazards are leak, reverse flow. Vapor leak into the fresh gas line can cause sensitized ability to react halogenated agent or trigger malignant hypothermia. Contaminants in the vapor chamber, obstructing to fresh gas flow due to problems in mounting system, interlock malfunctioning, concentration dial in wrong position, physical damage. These are the various hazards that can be seen while using these modernized vaporizers. This is the summary of various vaporizers and their types and the characteristics of each vaporizer. Conclusion: inhalation anesthetic agent is an integral part of balanced anesthesia. Hence, it's very, very, very important to know functioning and the working principles of all vaporizers, at least the vaporizers that we're using in our day-to-day practice. The device intended to deliver vapors or of inhalation agent to the patient. It is anesthetist who is responsible for all these things. So we must be aware of at least we must be aware of the basic principles of the vaporizer that we are using in our daily day. Thank you so much for your patient listening. And now the topic is open for the discussion. Thank you, sir.
Thank you, Santosh.
Thank you, ma'am.
Thank you, Santosh.
Thank you.
Sir, Anaconda is a disposable medical device. So that device we can keep in a HME filter area. That means YPs, when you're connecting the YPs to ET tube, no, that place you have to connect. So a special syringe pump is there. So that volume vaporizer injection is coming, and that device area is vaporizer coming and it goes to the inflow. So we can monitor the external flow also. So you can monitor the percentage, how much value, MAC value is gone. So that in the load that space 50 ml, sir. And that volume, patient tidal volume is 200 ml also. That time also this device will act as in the anaconda. Any question?
Madam, Anaconda is disposable or reusable? Hello.
questions among sir Shrikant, Shekhar, Chaitanya, Naveen?
Is Anaconda disposable or
seniors.
reusable?
This Anaconda disposable medical device. We can use in the vaporizer and sedation also.
Madam, good morning, madam. సంతోష్ డాక్టర్ సంతోష్ మేడం
Sir,
మీరు
morning, sir.
పిఎన్బియా లేకపోతే ఐ మీన్ మీరు పాస్డ్ అవుటా
Sir, నేను డిఎండి స్టూడెంట్ సార్.
స్టూడెంటా మీరు? ఓకే, సో నైస్ క్లాస్.
థ్యాంక్ యూ సార్.
నా పీజీలో కూడా అర్థం కాలేదు. ఓకే, లెట్ మీ ఆస్క్ ప్రాక్టికల్ క్వశ్చన్. వెన్ డూ యూ థింక్ ఆఫ్ vaporizer when you're doing a case? Tell me a
Sir.
few conditions when you will think of something with vaporizer.
So basically, whenever there is a leak in system, so that is where we think about the vaporizer, sir, because most of our systems are usually in proper condition. And at some point of time, the interlocking system is not correct, and the locking system might not be correct. If you do not lock, whenever they're inducing the patient, when you're checking the system, we'll check about the vaporizer also, sir, because the locking and the positioning and whether the vaporizer has enough volume of liquid or not, and the rotator dial is functioning or not. That is when we check about the vaporizer.
So when your bellows is not working properly,
Yes, sir. And whenever the bag or bellows are working not properly,
and the
so
patient,
this is one area where we expect the leakage from.
one more thing is when patient is not recovering, at times we may forget to close vaporizer.
Yes, sir.
Okay. And next thing is, even though we are putting high concentration of vaporizer, pressures are not reducing. Especially in CT cases, they use lot of okay. One more thing is, do we have any check tests for cases? Like when we go to a new place, like in freelancing, we go for doing cases. We check the bag, circuit, and all. Any such thing for vaporizer?
Sir, last time when I went to meet one of my friend in KGH in ENT department, they have this minor OT kind of thing, and they have this basic boil system with the boils vaporizer, sir. That is the only place where I have seen other kinds of vaporizer. Other than I've seen much of this various vaporizer. I have seen Tech 6 and Tech 7 in our institute, and basic boils and like Goldman's vaporizers in my colleague's hospital, but nothing else.
Thank you. Thank you.
Thank you, sir.
Hello. Any experience of a halogen vaporizer using a Horlicks bottle?
No, ma'am.
Me కాదు. My seniors.
Goldman లేదంటే యాక్చువల్ వ్యాపరైజర్ టెక్
So
టెక్ 7 ఆర్ టెక్ 5?
no.
ఏది?
Any halogen using in a Horlicks bottle.
Yeah, we use it, madam.
So that's why I'm asking any experience of halogen using in a Horlicks bottle.
And Particularly for MTPs and suction evacuations.
We used to use halogen, madam, regularly in PG.
So we are PG time. Goldman Smith is present means we are rich. That OT. So Horlicks bottle is means we are poor. I think Ramana Prasad is not there. They have a lot of experience.
Ramana Prasad sir will have a lot of experience with halogen.
Next, Santosh, change the anaconda next Aldan. And one more thing in desflurane, if normal temperature, it gives the variable bypass, and if temperature increases, immediately that change to injectable one. So that
Yes, ma'am.
point is there, particularly
With the text, the restaurant advertising.
yeah, that point we have to tell. And tech 6 next to bimetallic strip, that is two varieties. In old version is bimetallic strip is there. The whenever is temperature is increasing, that time that strip changes the shape.
This one, as
Yeah,
slide.
that changes the tape and give the concentration more. And
Yes.
another modeling is that strip is changed to shape like a spiral shape. And the new version is not there. So some vaporizer, another companies have not a strip. That strip changed to coil type.
Penlon, I think.
Penlon or something. And one more thing, and you kept a saturation vaporizer saturation pressure or something. You kept that slide, no? Show me that
Yes, ma'am.
slide. So that desflurane have how much percentage?
Santosh?
Yeah.
669.
This that desflurane have boiling point 22.8, but SVP
The
is very
saturation
high.
pressure is very high. Yes.
Very high compared to other one, especially for
Yes.
desflurane.
Yes.
We are using isoflurane and sevoflurane. Anyone have any experience of enflurane? I didn't see that one.
No, madam.
నీకు కాదు బాబు.
Shekhar sir.
Shekhar, you are asking some question, na?
Santosh, where will you use anaconda?
Sir, near the patient end, sir.
Where will you use? In what situations you will use anaconda? Anaconda is for a particular thing. Only in particular areas only you can use anaconda, not all patients.
We can use in ICUs. Patient is mechanical ventilation. So we need some sedation or some thing. That time you can use that anaconda device. It acts like a HME filter and vaporizer and sedation both. Everything.
Oh, okay. Okay.
Dr. Chaitanya, anything you are adding?
Good morning, ma'am. No, ma'am.
You're not adding anything. So frankly speaking, during my PG time, I didn't understand this volatile tech. What is tech 3, 2, 1, every. So I didn't read that chapter also. During exam also I skipped that question. Only I read about the sevoflurane, isoflurane, halothane, only that topic only. Thank you, Santosh.
Thank you, ma'am.
Shall I close? I think Srikanth we're busy with the
Yes,
time.
Srikanth sir is not available, so
On sir also not available.
no, ma'am.
Anything? Omkar, Vamshi, Shekhar, Naveen,
I think Shekhar sir is available.
Dr. Mahesh, Kishore, Dr. Devika.
I'm not helping on the students.
Okay. Thank you. Thank you
Thank
to
you.
all.
Thank you.